Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're in Chapter 9, studying the conics section. We're in our second section. The first video was over parabolas and circles, and today we're going to be looking at ellipses, which is this diagonal cross section all the way through, but not through the bottom, because if I went through the bottom, I would have a parabola. So again, I'd like for you to kind of recognize we've already studied circles and parabolas. Remember, parabolas only have one term being squared. Depending on which one's being squared, if it's y equals x squared, it's a vertical. And if it's x equals y squared, then it's a horizontal. And same with ellipses, which is what we're going to study in this video. We could either have horizontal or vertical ellipses. And I'll tell you the difference between the two. First of all, an ellipse is generated from 2 points, where if you remember, a parabola only had one foci and a directrix, and was defined by all the set of points that were equal distance from the foci to the directrix. That's a parabola, but an ellipse has two foci, and this circle represents, or this ellipse, circular shape represents the ellipse being drawn from two fixed points called the foci. And the sum of this distance from the two fixed points is a constant sum. So that's kind of where we get the x squared plus y squared. And we have some a distance, which is the distance from the center to one of the vertices. And we have a b distance. So if this is a, this would be my b distance on the minor axis. And then we're talking about the larger number. If the larger number is underneath x, it's a horizontal. If the larger number is underneath y, it'd be a vertical ellipse. So taking a look, again, general form, if it's at the origin, then I don't have to worry about h and k, and then the general form is just an x squared plus y squared form. In fact, if a and b were equal to each other, it would actually be a circle again. So there would be the a distance, there would be the b distance. So if these two numbers down here are equal to each other, I would just multiply both sides by that number, and that would become your radius squared. So we also have something called the vertices. There are 4 vertices. There's 2 vertices on the major axis, which is the longer, and 2 vertices on the minor axis. And they're directly above and below the origin. So if it's centered about the origin, if the center is around the origin, and remember this distance is a, and then this distance is b, it kind of follows that that would be the points that we're finding here. So again, let's just go to our first example. You can see here a is 4 and b is 2. Now remember, a is always the larger number, and the larger number tells me whether it's the major axis or the minor axis, and since it's underneath x, I'm going to go that distance, so 4 units. Well, by the way, h and k, it's centered around the origin, so we know it's starting here at 0, 0, so I'm going to go 4 units to the right and 4 units to the left. That's my a distance. The b distance is 2, so I'm going to go 2 above and 2 below. And so to graph this ellipse, there's the value of b, and I'm done. For this one, if it's not in that standard form, we'll want to get it into that standard form. Remember, ellipses are always set equal to 1. So I probably want to divide by 1764 here. And I'm going to divide every term by 1764. And then I'm just going to bust out my calculator and try to simplify this and set it equal to 1. So if you pull out your calculator here and ask it to convert this fraction into a fraction by hitting math, enter, enter, you'll get 136. So I'm going to put x squared up here and the 36 here, and then I'll repeat the process for 36 divided by 1764. And I'll hit math, enter, enter again, and I get 1/49. So this time, the larger number, A, on the major axis is 7. So I'm going to go 7 above and 7 below, a little bit off my graph. Again, notice that it's centered around the origin because there are no H and K values. So I know that H and K is 0, 0. I'll show you a different example of that in a moment. But I also see that A equals 6. So I'm going to go 6 to the right and 6 to the left. So again, this is my graph is a little bit off on this. But here's a little bit better picture. If I went by 10 by 10 graph, you can see I'm up the major axis here. A this time is vertical, and the B distance is horizontal. So it almost looks like a circle, but it's a slight ellipse. So here's H and K, which is going to be the center of the ellipse. So it may not be centered around the origin. And here are some of the notes, again, that I'll post this onto Blackboard so you can get some of these notes. This is important. A is always the larger number. It's going to determine whether it's horizontal. So if the larger number is underneath X, it's horizontal. If the larger number is underneath Y, then notice that it's vertical. These notes maybe go a little bit more in depth than what you need because I don't think you need information about the foci or how to find the foci or the ordered pairs. So this video doesn't go to that lesson, but you can certainly find the endpoints. So to graph this ellipse, I notice that A is 4, but even more importantly, I notice that the center is no longer at 0, 0. So I need to find that center first, which is, whenever you see parentheses go the opposite direction, 2, -1. So here's that center point, and then I'm going to go 4 units along the Y. So that's 1, 2, 3, 4 up, and 1, 2, 3, 4 down from the center. And then I'll move a B distance of 2, and I'll go along the x-axis from the center, 2 to the right and 2 to the left. Oops, 2 to the left would be here. And so I see this is my nice ellipse where B is 2 and A is 4. And I'm done. I've graphed the ellipse. I've got it centered about the point 2, -1, and here's how the author drew the picture. But again, the important thing is that this distance is 2 and this distance is 4 because A equaled 4, and that's going along the Y distance. So even a little bit harder problem, if it's not in standard graphing form, we're going to collect the x terms together. In fact, I would almost encourage you just to factor out a 4 when you do that, because we can't complete the square with a leading coefficient. And then I'll collect the y terms together. I don't know, no need to factor out a 4. I can't factor out a 4. So this is y squared plus 4y plus blank. And then you don't have to do this, but I always like to throw the 4 on the other side. So I'm going to say -4. Since I created 2 blanks on the left, I'll create 2 blanks on the right. So completing the square over here, I call it the star step. I take half of the middle term, which is 1, and square it and get a 1. But be careful, you don't put a 1 over here on this blank. This is actually a 4 units that you've created, because when you distribute that 4 back, it's actually a quantity of 4 is the weight that you added on the left side of the equation. Over here, the middle term is 4. I'll take half of it and square it and get another 4. And there's nothing to distribute here, so it actually is a 4 on this side. So, completing the square, I get 4 times the quantity, x minus, it's always just this number, 1, quantity squared, plus, this is a perfect square, y plus 2, again, always just this number, quantity squared, equals 4. Well, remember, ellipses are not set equal to 4, they're set equal to 1, so I'm going to divide each term through by 4, and I'm left with x minus 1 quantity squared over 1 plus y plus 2 quantity squared over 4 equals 1. Now the larger number here is 4, so I'll take the square root of it and get the value of a, and I know that it's a vertical ellipse because the larger value is underneath the y value. And I also notice that the center is no longer at the origin, it's at h and k. So remember, this is x minus h, and this is y minus k, so that means go the opposite direction. So the opposite of -1 is +1, the opposite of +2 is -2. So I'm going to plot the center of this ellipse at 1, -2. There's the center. I'm going to go 2 units above and below that. So there's a point on a vertice on the major axis and a vertice on the minor axis. And then I'll go 1 unit along the x distance from the center, and then I'll graph this ellipse. So the value of b is 1, and the value of a is 2. There are some other points of interest here called the foci, but again, for the sake of this video, I don't think you'll need to know that in Mat-073. When you get to college algebra, we'll extend our discussions to the foci. Ellipses have practical applications. We're not just torturing you stuff. As you may know, the Earth revolves around the sun in an elliptical manner, and the medical field has several applications of it as well to help solve the problem of kidney stones, and then there's other practical applications. So you may use this one day in the medical field or in science studying planetary orbits. Hope this video was helpful. Email me with your questions. Thank you.